Hi, this is a very quick video just to, I don't know, put your mind at ease if you're ever thinking of making a circuit board, just to give you some flavour of actually how quick and easy it really is. And I'm talking about something like this. Okay, it's in a panel, but this is actually a small LED controller board which I've made and sold a few of. So, you know, they're quite nice. It's USB-C one end, it's got WAGOs the other end to connect to an LED. So, really quick rundown of how I put it together. Obviously, there's lots and lots of detail behind the scenes you're going to have to learn, but just to give you a flavour of what's involved. So, the first thing is I'm using KiCad to do the circuit board design. It's free. So let's get that up. And I'm going to start with the schematic editor. So what you have here is a schematic for that LED board. Now the nice thing is I've built up a lot of component templates and footprints over the years. So when I find a new component I want to use, and I look at something like lcsc.com, for example, when I find a new component I want to use, I look at the data sheet, I check out whether there's a 3D model for it, I find the footprint, I find a suitable symbol for it. Now there's a lot of symbols already in KiCad, so a lot of things I don't need, but it's a little bit more work with a new component. But the nice thing is I've built up a whole load of components and whole sections of circuit board now, which I can copy and paste from other boards. So if you have a quick look at this board, it's got an ESP32 processor with a reset button and a capacitor resistor startup and power. It's got an LED that I'm going to use as a status LED. It's got a USB-C socket. It's got a USB-C connector on the board so it can be programmed before I take it out of the panel. It's got a power supply block which has a load of components on a common footprint. This board I've added an infrared receiver, a connector to drive LEDs, an ADC divider for measuring the voltage, and a microphone. So they've all been thrown on the board. What you do then is you move all of this to the PCB editor. You can edit the various layers. That's the top, that's the bottom. You can show them all together, but it's a bit of a jumble. And this particular design, I have a 70 by 70 panel. You can order these without putting them in a panel, and they will do that for you. I like to put it in a panel because then I can decide exactly how it's cut out. I can have a barcode on it. That's what that square is, a placeholder for a barcode, and make the panel exactly as I want. But you don't have to. The design is quite simple. You place all the components on, and then you draw in all the tracks. And you might think that's obviously very simple. Well, it's actually easier than it sounds. For a start, if we look at the schematic editor, this says what's connected where. So these little labels say what's connected where all over the board. When you import it into the editor, it knows all about those. So before you import it, let's go back to the schematic editor. You can run a test which does a rules check for you, and it says, yeah, it meets all your rules. So you've not left things unconnected, you've got proper do not connects on things. And if I go to the PCB, it knows all those rules and knows those connections. And again, I can run a check. So on here, we can run a check, and it checks a lot of things for you. Now, this is all to do with things like how close is this wire to this pad? Is it too close? You can just about see the defined outlines on these. But it also checks everything's connected where it should be, which is really nice. So that gives you reassurance that this matches the schematic now. Really good. Another really good thing they do is they have a 3D viewer. Now you'll like this. So I can look at it, I can spin it around, I can see how all of the components fit, I can see all the silk screen in meticulous detail. And that is a really useful tool. So having done all that, designed my board, put the components where I want, tracked them all, decided where the tracks go, checked it all to make sure it's right, I then go and say, make a file with a fabrication toolkit for JLC. I say generate, and that makes the file. So What then? How do I get the PCB into my hands? Well, it's actually quite easy. Go to JLC, I'm logged in already. Tell it I want an instant quote. I usually pick 10 because the overheads in ordering 5 are not ideal, but you can obviously do the maths yourself. Import the Gerber file, and this is what has been produced today by that production toolkit. Dum-de-dum-de-dum. Takes a second. Okay, you can see what it looks like. You can pick how thick it is, what colour it is, loads of other settings. You can tell it you want a 2D barcode somewhere. That's why I've got that rectangle in there. If I tell it to specify position, it'll put it in the right place for me. And then I can say I want the board assembled. Now, in my case, I'm using components, which means I can't use the economic cheap assembly. If you can, then you can get really cheap boards. They basically make up a huge board with lots of designs on, break them all out and send the designs to each person. So standard, and I'm going to tell it I've already done the panel. So it's already got the guardrails. They've got a specification on what you need for a panel. You need this guard area and fiducials and holes and things so that they know what they're doing. There are a load of options. I normally have to put a remark in saying do not bake, because I'm using a diode that's moisture sensitive, and so they want to charge for baking it. There's no point on a small one like this. It costs more than a scrapped board to pay for the baking, and I've literally made thousands of these without the diodes having a problem. So, but I have to tell them, because otherwise they come back and say, do you want to bake it? And that wastes hours of me getting an email in the middle of the night and then having to email back. So there's usually a couple of things I have to say in there, but you do a remark. And then you go on to the next stage, and you can see the top and bottom of your board. And you go on to the next stage where you, again, the production files, the bill of materials and the position file. Okay, and then you go on. It lists all your parts. Now, in my case, I've got 2 parts with the same value with a slightly different description. I won't go into why, but it means I've just got to say, yes, they're fine. But normally you don't. You should check that these are actually the parts you want. But what you can do is part of the fabrication toolkit, I can put in the schematic, the actual part number of each part, so that there's no ambiguity and I get exactly the part I want, which makes life a lot easier for reordering. And then this is the cool bit. That's my circuit board with all components. And I can go in and check they look right. So that's purple dots where pin 1 is, and I've got a mark there on my silk screen. Yes, that's pin 1. That's the right way round. Same with that dot on there. Same with that dot and well, that has to be the right way around. It's particularly that dot and that dot there. So are all the parts in the right place? Do they look right? I can go into 3D view and check. Yeah, the heights look sensible. They're not going to be a problem. Nothing's going to clash. Looks the way I expect it to. There is one caveat I would say. These 3D models are really good, but JLC have been known to have a capacitor the wrong way round. And I've told them about it and they haven't fixed it. They're very good if you put a capacitor the wrong way round and you've marked the board, so I put a plus because it was tantalum capacitor, they will spot it and turn it round for you. But they won't tell you they've done it, so you don't know you've got it wrong. You just get boards that work. And it's really annoying if the 3D model is showing you it the wrong way round because you think you've got it wrong. So you adjust your position file to put it right, and it looks right, and then they correct it on the board, and it is right, but you didn't know they're having to correct it every time, and you run the risk that they don't correct it one day. So it would be really nice if they fixed that. But that's the only criticism I've really got of this 3D model, is just occasionally these 3D models aren't correct. And I would hope they will correct them. But generally, very good. And especially important for some complicated positions, like the position of this USB connector. I can see that it's right. In fact, I can zoom in enough to see that the little plastic nipple in the bottom in that hole in those 2 places matches the positioning holes exactly. So I can be sure I've got the position data for that right, and the same for that. So it's really quite important. It also helps you spot that you've accidentally put a large capacitor on small pads by mistake and that sort of thing. You can really see you've got it right. And then you go on next, and it's got the pricing, and you can literally order it now. There are some overheads. There's a setup fee and feeder fees and things. This is why ordering 5 is often not worth it. But you can literally order it. You can pay extra to have it quicker. So what happens then? What happens next? Well, I order it with DHL because the other couriers have proved to be crap. But normally, for an order like that of 10 or 5 or even 20, I've got it on my doorstep in 7 days. Sometimes 6 days. Which is ridiculous. A complete assembled board. So I've got a bag of these that I ordered a week ago. That are exactly what I want and they work perfectly. It is amazing. So don't be put off if you're thinking of making a PCB. It's not stupidly expensive. It's not actually that hard. You can afford to order it with extra test pads and things so that you can solder things yourself if you want. Try it out, and if it works, great, and if it doesn't, you can work out what you've done and order another one, and a week later you've got more boards. It's amazing what you can do these days. So yeah, I'd go for it. And yeah, JLC seem to do a good job. I'm sure there's others, but JLC seem to do a really good job. It just works. So yeah, absolutely great.